Welcome back, everyone. It's time for Lightning Talks. Thank you for joining. I'm Sharon Amoja, joining from Nairobi, Kenya. We have 7 Lightning Talks that are lined up for you, and thank you.
Hi, my name is Oliver Fritz, and I work with the Heidelberg Institute for Geoinformation Technology, the HiGIT. And today I'd like to talk about being awesome with R. More specifically, I'd like to talk about our new awesome R package for OpenStreetMap data aggregation and extraction. So what's awesome? The awesome API has been developed by HiGIT, and it lets you analyze the rich data source of OpenStreetMap history. You can get aggregated statistics on the evolution of OpenStreetMap elements, and you can also retrieve geometries. At the back end is the OpenStreetMap history database, which has been designed for efficient storage and access to OpenStreetMap history. The new package tries to unlock the potential of awesome API for spatial data analysis with R. You can install an early version of the package from our GitHub repository. So please go ahead and give it a spin. I will now just present you quickly with 3 awesome queries as inspirational examples of what you can do with it. First of all, it's very easy to query for element count data over time with awesome. In this example, we query for the amount of breweries over a period of 10 years in the region of Franconia, and we comfortably pass the results of the query into ggplot2 for a nice and quick visualization. But with awesome, even much more complex aggregation queries are implemented very comfortably. In this example, we don't query for the amount of elements, but actually for the ratio of the length of highways with a cycleway tag to the length of highways without such a tag, and that for the 7 provinces of the Netherlands. Again, this is just a very few lines of code, and we can pass the results immediately into any of our favorite thematic mapping package functions. But as I promised you in the beginning, you can not only aggregate data, historical data from OpenStreetMap with awesome, you can also retrieve geometries from the OpenStreetMap history. In this example, we query for building polygons for the Heidelberg Weststadt, for yearly timestamps between 2008 and 2021. Again, it's just a few lines of code and a few lines more of data wrangling, and then we can pass the results into the map view function for a nice interactive visualization of the year of creation of the building feature on OpenStreetMap. So if you got inspired, please go ahead, install the package, give it a spin, and as this is a very early version, wait for even more awesomeness to come. Thank you very much.
Hi, I'm Richard Fairhurst, and I'm going to talk about the new version 2.0 of tilemaker. Tilemaker is a command line utility that takes OpenStreetMap data and makes vector tiles out of it. Vector tiles are the wonderful, amazing technology that make mobile-friendly, restylable, interactive, rotatable, smoothly zoomable maps. Most vector tile generators, you can see here from this diagram with the universal symbol of a database, you feed your OpenStreetMap data into a database, and then the generator pulls it out again and makes vector tiles out of it. Tilemaker gets rid of the intermediate step. You just take your PBF, put it into tilemaker, and tilemaker gives you some vector tiles. This is really good because you don't have to host, maintain, or tune a database. It's very well suited for independent artisan developers who are the best bit of the OpenStreetMap ecosystem. And it's great for mobile maps because you get a nice, easy, offline-friendly pack of vector tiles at the end of it. This is how it works. We read the OpenStreetMap data into memory and into on-disk temporary storage. We have a little bit of script written in the Lua programming language to pick out the ways and nodes we want, filter them by tags, and write them into vector tile layers. And this all comes out as an MB tiles file. Just one command. That really is as easy as it is. Tilemaker, input file, output file. That's it. That's all there is to it. So I'm talking about 2.0 today, which we've just released. Lots of great contributions to this from lots of different people, but I will particularly thank Wouter van Kloinen, who has come up with some amazing improvements to the code base. One of these is using on-disk storage, so you no longer need huge amounts of RAM to do country-level extracts or even bigger. The geometry handling is much more robust, so no matter how terrible the multi-polygons might be in OpenStreetMap, we can cope with them. It's much faster, lots of other good stuff. I'll just pull out from the bottom there. It's compatible with the Open Map Tile schema, which means that you can generate vector tiles and use the many styles that have already been developed for Open Map Tiles. Lua programming language is great. There are 578 ways to tag paths and trails and tracks in OpenStreetMap. With Lua, you can boil them all down to one or two. It's a really good way of handling OSM data, and we already see it in OSM2 PG-SQL and OSRM, which use the same approach. So it's super fast because it's written in C++. It uses the Boost geometry library, which is a really good library for chopping and dicing geometries. It's pretty much parallel all the way through, so the more CPUs you've got, better. The faster disks you've got, the better. And is already in production all around the world. Lots of people producing maps from it already. Using my home server, then I can do a map of Oxfordshire into vector tiles in just 8 seconds from the GeoFabric extract. Britain takes 24 minutes. France takes 34 minutes, which I think is pretty good, considering how much our French friends love their buildings. Whole of Europe, 7 hours 30. If you throw more CPUs at it, then it will do it even faster. GeoFabric have a really amazing machine with 8 gazillion CPUs, and that has managed to do Europe in 2 hours 30, which is great. So that's the URL for the code. We've got a website now at tilemaker.org. But just before we finish, I'm going to have a live demonstration. Of course, it's not really live in that this is recorded, so if it screws up, then I can do the whole thing again, but I don't think it will. So, tilemaker, right, let us do input. We're going to have a freshly downloaded PBF, and we'll just have a county extract for now. Planet Oxfordshire, there we go. Output, put it in our debug directory. Right, and watch this go past. So there you go. That's all the layers we've defined for it. It's gone through the nodes and the ways already, and you can see it's going through zoom level by zoom level, writing out the tiles. This will all go into an MB tiles file, and we can then serve that up using a little homebrew server that I've written. So change to server directory Ruby Oxfordshire. There we go. That's where we did earlier. So we just switch across to a browser. Okay, and here we go. You can see the server's busy working. And this is it. These are our vector tiles. We can zoom in. Beautifully smooth. We can see all of the features there, the buildings. You can see only 39K for the vector tile, which is pretty good, nice and mobile friendly. And as we zoom out, Tilemaker has simplified everything and filtered out stuff that we don't need at the smallest zoom levels, so the vector tiles stay nice and performant. There we go. Thank you very much. Do play around with it all on GitHub, and I will be fascinated to know what you make with it. Thank you.
Hi everyone, it's a great pleasure to share with you this project of the GeOsm family. Our goal is to connect and empower communities with mapping data. I'm Willy Franck, SOB, the chair of GeOsm community based in Yaoundé, Cameroon. The context of our project is the multiplicity of software, services, and actors around OSM. OSM ecosystem is made of different and variable tools around OSM. have for the contribution desktop and mobile tool, have many users and many organizations using OSM tool. Our positioning is bridging together communities by facilitating exchange within the same network. The goal is not to replace existing tool, but to create bridges for the community. How do we connect and empower communities with mapping data? We rely on three pillars: data, connect, empower. Empower community means give power within the community. We need to work on issues like transparency, accountability, and also to foster creativity and innovation. Today data is all: me, myself, my data, and I. So access to data should not be a luxury. We really need to make this available for all the communities. We also need to connect our experience, connect the know-how, connect the ecosystem made of variable actors. You have professionals, you have startups, you have lab, you have universities, you have institutions. So it's very important to work together if you want to achieve those sustainable development goals. Our objective is to allow the exchange of information around mapped data and to facilitate the spatial dialogue of stakeholders on a project related on the territory. So we have map profile so that each person can be taken into account. We have defined their frustration and also their needs. If you want, you can just consult this later. But what is important here is that you have different actors. And also, if you want to summarize, you can say the OSM contributors. You want to be more visible. You want to show the project you have done. You also want to find new opportunities. You want to be part of a community. You want to be connected on groups, events, and projects. Another actor is the GIS technical manager and the program manager of the NGOs. All those actors want to monitor their organization. They want more communication, more transparent about what to do, also to recruit or call some contribution. They also need opportunities, more coordination and transparency around all those issues. A simple citizen wants to be involved also, wants to find out project around his area and also to give some report on his needs and what he wants for the local development. So GeOsm is a social network around cartography. As you can see on the screen, you have the screen with the people, the group, the project, the pages, and the events. You can customize your map, have the groups, you have the project, you have pages of events. You have all the initiatives, you can have the posts, you can like, you can share, you can have the connection with the sustainable development goal. So we have done a lot of progress in order by end of the year to have the first version of the platform available for everyone. So thank you for your attention. If you need to know more about our project, feel free to ask your question. GeOsm is a project for everyone. It's a global project. So we have already built the spatial infrastructure for the whole countries. Now we just want to create and to connect these social network entities. So feel free to ask your question. Thank you.
Hello everyone, welcome to this lightning talk, State of the Map Africa 2021. My name is Sharon Omoja from OSM Kenya. State of the Map Africa is a biannual regional conference that celebrates the culture of open mapping, open data, GIS, and its impact across Africa. The conference brings together contributors and participants from Africa and around the world to discuss the challenges we face. We also learn and we celebrate the years of collaborative mapping in Africa. Our this year's conference objective is to build on the strategy we have envisioned for OpenStreetMap in Africa as a renewed, strong, and a growing network, and as part of the global OpenStreetMap community and the OpenGIS movement. Our first State of the Map conference happened in 2017 in Kampala, Uganda, where we had over 150 participants from 29 countries, 23 being African countries. Our second State of the Map Africa conference happened in 2019 in Grand Bassam, Ivory Coast, where we had over 190 participants attending the conference from 39 countries, 28 being African countries. The third State of the Map Africa conference was to happen in Nairobi, Kenya, but due to the current COVID-19 situations across different countries in Africa, we decided to move the conference online as we could not guarantee the safety of our participants. I'd like to bring to your attention that the submission for talks is still open until 20th July, and we'd like to see you participate in the conference. So please submit your talks on our website. The registration is free, and so we'd like to see everyone at the conference. And also, if you'd like to support the conference, we have individual supporter and enterprise supporter tickets for supporting the conference, and we also have sponsorship packages that have been modified for the virtual conference. Please join us on 19th and to 21st November, as we don't want to leave anyone behind. Thank you.
Hello, my name is Jennings Anderson, and this is a quick overview of the paid editing activity in OSM in the past 2 years. This will simply be a quantitative summary of the work that paid editing teams have been doing. There are other talks and panels at this conference that discuss this activity in deeper detail. The past 2 years have seen an increase in the number of paid editors in OSM. I use this list of organized editing teams on the OSM wiki to identify paid teams, editing teams that are associated with corporations. From this list, I identify any company-specific hashtags used in change sets or any self-disclosing sentences in a mapper's OSM profile, such as, "I work for Amazon Logistics." For those curious, this is a slightly different approach than manually tracking individual usernames as I have in the past, because these lists are too dynamic at this point to continually monitor. This graph shows the general growth over time in the number of mappers working on paid editing teams. This is not an exhaustive list of companies nor teams, but it does capture the largest, most prolific. The past 2 years have seen a consistent increase in the number of paid editors in OSM. This map shows the location of all the change sets submitted since 2019 by each company. We can attempt to break it out by corporation, but it's a bit overwhelming to see. Perhaps the most important thing to note here is that areas appearing to glow white likely include edits from multiple data teams. Let's dig into this a little deeper. Apple continues to be active nearly everywhere except the United States, Canada, and Western Europe. Similarly, CART is active globally. Facebook continues to be very active in Southeast Asia, specifically with AI-assisted mapping in both Vietnam and Indonesia. But we also see an expansion around the globe, likely as the team is performing data integrity checks and validation for the daylight distribution, which also make their way back upstream to OSM. Microsoft continues to be active in Australia and New Zealand, with newer activity in the Western Hemisphere. In the United States, they appear to work on entire states, as evidenced by the state boundaries. I grouped these two data teams together because of the formerly shared membership between Mapbox and DevSeed Data. These teams continue to be active globally. The Amazon Logistics team has been primarily active in North America and the UK, digitizing a number of driveways in cities and suburbs. More recently, they have expanded to more rural parts of the United States, and additionally, we see much of Germany appear as a focal point. A few other regional companies. Grab is very active across all of Southeast Asia, while Digital Egypt remains active primarily in Egypt. Telenav focuses on North America, and Rocket Data is more concentrated in Eastern Europe. NextBillion.ai is active in various parts of India. In terms of the overall number of mappers active in OSM, we see consistency in the amount of paid editors in recent years, especially among the more active mappers. The top graph shows all active mappers each month. The orange caps represent paid editors. The bottom chart counts only mappers making more than 5 change sets in any single country each month. We see a larger percentage of these mappers are corporate, but the consistent size of these orange caps shows the relative percentage has remained consistent over the years. Grouping by country, we can show the amount of change by paid editors, showing how editing teams focus on specific regions and then move on. In the last 2 years, as shown on the bottom row, we see a shift from editing in Africa to South America. Per country, we see the top 50 most edited countries here. First is the United States, with Amazon responsible for the lion's share of editing. Second is Indonesia, seeing Apple, Facebook, and Grab being the most active. And third is Brazil, with Apple and Cart being the most active corporations. Thank you. Here's my contact information, and if you'd like to see the charts presented here and more, please check out my OSM diary. I've been making an effort to share all of my research there. Thanks.
Hello. Hi. Mambo VP. Welcome again to the State of Map 2021. I am talking about the Tanga building imports as well as the community mapping activities. My name is Antirius Kawamala, Kawamala being my OSM name. This is the view before we have uploaded our building datasets to OSM. When you go to osm.org, this is what you will find. There are less mapped data, less buildings, whoever you can mention. So briefly, I just want to give you in a nutshell what are these building footprints, where did we get them from, how were they being obtained, who brought them to us. These building footprints is the result of the manual digitization done by the students from R&D University, co-working program between the R&D University students and the Tanzanian government. And in these buildings are in a total number of more than 500,000 buildings covering entire region of Tanga. And this is the view of Tanga after we have uploaded the building footprints as well as the micro works done by the students from R&D University, as well as the local people, the local youth, the adolescents, also the elderly people who are found in the area. Talking of the microworks, we are getting together between the community part as well as the technical part, whereby these local people with the local knowledge are trying to work together with the experts who knows how to contribute data, who knows how to write data, who knows how to write the tags on the buildings, how to write the names of the streets. So that's how we can work together with the community. So here you can see the field mapping with the Hardy University students, whereby we did the metadata contributions and the less mapped areas using the local people with the local knowledge. So we used their knowledge into contributing this knowledge to OSM. Spatial coverage, I guess you can all see the incredible work which has been done by the students as well as the community. That's the snapshot of what has been covered, just combining the knowledge using the experts as well as the local people. So this is kind of the snapshot or the heat map showing the spatial coverage of where we have tried to map the data, where we have tried to collect the metadata, the attributes of the buildings, what the building use, what's the use of the building, is it the shop, is it the farmers, or whatever you can tell, all the information that can be put to OSM. So this is one of the areas, the spatial coverage with the art university students as well as the community. Last but not least, we have been having these local meetings, local community mapping parties with the local community. We are using the field papers whereby we use the local youths and adults in Tanga so as to enrich all the data to OpenStreetMap.
This paper is one of the chapters which is found in Dodoma, and it is established at the Institute of Rural Development Planning since 2017. And the aim of this book is to try to show the problem which is facing our community, and it tries to address this problem to various authorities in order to get the solution. So far, we get the chance to involve and being participated in different activity and the projects which were prepared by different NGOs and the institute as an institute. So far, we try to engage in load import project which were prepared by OMBTC, and in this project, we try to import and to show the road condition which is found in our community, and also I try to show different services which we have found in our community. So there is a chance also to participate and to be very close to our community surrounding us. By the training and the skills which we gain from this project, it builds us to be capable of continuing supporting our chapters, but also supporting our fellow students in their fieldwork and their fieldwork program. The institute gives us the chance to prepare and training fellow students on how they can use the ODK and the GeOsm in data collection, but also mapping of existing infrastructure which were found at Mpwapwa. And this data we are processing by using GIS in order.
My name is Shaban Magawira. We're from Dodoma. I'm presenting this chapter in Dodoma, but also I would like to share with you some information which relating IRTP use methods, but also some activity which were performed before. By my experience, I was used to be the youth member president at IRDP in Mwanza, but when I'm coming in Dodoma, also I tried to support the activity which were conducted by IRDP youth member here in Dodoma. So I'm trying to find new members, but also to find to create new leadership for IRDP youth members here in Dodoma. So now we are active sometimes because of the vote for the teamwork which we have for our leadership, but also for the support which we get from the institute.
Thank you to our amazing speakers, Oliver, Richard, Willy Franck, Jennings, and Antirias for the amazing lightning talks that you've given. That comes the end of the lightning talks, and see you in the next session. Thank you.